Okay, so we just finished chapter 3, and the main purpose of chapter 3 was to develop rules and techniques that will allow us to find derivatives of functions quickly and easily. In chapter 2, we learned the definition of the derivative, which it's a limit, right? But the idea is we didn't want to have to apply that limit definition every time we wanted to find the derivative of a function. So in chapter 3, we talked about all of these different rules and techniques that will allow us to find derivatives quickly. Now, there were also some sections like section 3.7, rates of change in the natural and social sciences, 3.8, exponential growth and decay, 3.9, related rates, 3.10. Some of these were more of applications of differentiation, so you could have potentially put that in chapter 4. You know, related rates, that's an application of differentiation. But for the most part, we talked about these different rules and techniques for finding derivatives. So now before moving on to chapter 4, what I want to do in this video is kind of like a derivative mini marathon. We're going to find the derivative of 50 different functions. These are all taken randomly from any of the concepts that we talked about in this chapter. And they're in no particular order. The level of difficulty, it's in no particular order at all. It's completely random. This is great. So if you have a cumulative final exam coming up, or if you've just been going through all of the sections on the different methods for finding derivatives, and now you want to take a step back and come back and cement all of the knowledge you've learned, then it will be really helpful for you to work all of the problems that we're about to do in this video. It's a great way to bring everything together, to put a stamp on the concept of the derivative, of finding derivatives of functions. And before we get started, let me show you the rules and techniques that we learned for finding derivatives quickly and easily. So we were either given a rule, which is like a technique for finding the derivative of a function that's in a certain form, or general forms of derivatives were derived for different types of functions, and we were given the general form of the derivative for that type of function. So like, for example, derivatives of trig functions or exponentials or logarithms. Here are the rules that we learned. So the power rule, the constant multiple rule, sum rule. So this is the sum or difference, plus or minus, right? The derivative of one function plus another function plus or minus another function, you can just find those derivatives separately and sum or subtract them. The product rule, the quotient rule, the chain rule. Okay, and then also derivatives of trig functions, inverse trig functions. Here we've got the derivative of a general exponential, a general logarithm, natural log of x, natural log of absolute value of x. All of these we saw were derived using one of these rules. For example, the derivative of an exponential was derived using the chain rule. But if we come across a function of one of these types, we're going to go ahead and just reference what's given here. In other words, we're not going to derive the derivative of sine of x from scratch. We're just going to reference these derivatives of trig functions, inverse trig functions, exponentials, etc. when we need it. Okay, let's get started. Okay, so again, these are completely random. We're not starting with the easy problems first. There's these 50 derivative problems that are given as review. We're going to work all 50 of those, and I'm just pulling from them randomly. Okay, so let's find y prime. So you look at this and you think, okay, quotient rule, or maybe you might think product rule if we make this 2x plus 1 to the minus 3 or 3x minus 1 to the minus 5. But you also might think, man, this is going to be exhausting. If we use the product rule, then we're going to have a double product rule because we'll have 3 separate functions of x that are multiplying. Or for the quotient rule, I mean, you've got every one of these is the chain rule by itself, and you've got a product rule here. You always want to have in the back of your mind the potential of using logarithmic differentiation. This is an ideal type of problem where we want to use logarithmic differentiation, because using the quotient rule or the product rule, we could do it, and it's fine, but it's just going to take a lot of time. But let's do logarithmic differentiation, and you'll see how it makes it much simpler. So logarithmic differentiation, step 1, take the natural log of the entire equation. So we've got natural log of y is equal to the natural log of this. So how do we simplify that? The natural log of this entire function. Well, what is the natural log of A divided by B? It's the natural log of A minus the natural log of, we could do this, of B. Okay, now let's continue to simplify this. So let's bring this 4 exponent to the front of the logarithm. What is the natural log of A times B? It's the natural log of A. So plus the natural log of B. So we've got so now we can bring down this exponent, 3 natural log of 2x plus 1. Okay. Let's distribute this minus sign. Okay, so now we've got this fully simplified. What we can do is, next step is use implicit differentiation to find y prime. Okay, so d dx natural log of y is 1 over y prime. Okay, d dx of 4 natural log of x squared plus 1 is what? So we're going to get 1 over x squared plus 1, and then times x, the derivative of x squared plus 1, 2x. So it's going to be 8x over x squared plus 1. Here, we're going to get 1 over 2x plus 1, and then times derivative of 2x plus 1 is 2, so it's going to be minus 6 over 2x plus 1. Here, we're going to get, so 1 over 3x minus 1, then times 3, so 15 over 3x minus 1. Okay, so now we solve for y prime. We multiply this entire equation by y, and y prime is equal to y times all of this. But then we just substitute this y back in. So we get y prime is equal to, so write out y. Okay. And then that times and there you go, that's y prime. Okay, so we're dealing with hyperbolic functions here. Let's get the derivative rules for hyperbolic functions. So to get y prime here, we need to use the chain rule because we've got the inverse hyperbolic cosine of something. What is the derivative of the inverse hyperbolic cosine of something? We can see here it's 1 over the square root of that something squared minus 1. So let's write that out. That something squared, just write it. Sine of h, the hyperbolic sine, well, this will be sine squared. I guess that's how they do it. Well, no, it would be sine h squared of x minus 1. Okay, times the derivative of that something. Okay, now this is confusing. This is going to really test your chain rule skills. So is this that something, sine of h, the hyperbolic sine squared minus 1? What's that something here? We've got, okay, inverse hyperbolic cosine of something, the derivative of the inverse hyperbolic cosine of something. Here's that something. So this is times the derivative. Like it doesn't say 1 over the square root of x. If this was 1, if this was 1 over the square root of x, then we'd have the square root of that something. It's 1 over the square root of that something squared minus 1. So then we just do times the derivative of that something. What is the derivative of hyperbolic sine of x? There's no more composite function here, right? It's hyperbolic cosine. Okay, so let's simplify this. So here are the hyperbolic identities. Does this help us? Sine squared of x plus 1 would be helpful, but we don't have that. So this is it. Okay, we need to use the chain rule. So the derivative of something to the fourth power is 4 times that something to the third power times the derivative of that something. What is the derivative of something squared plus something cubed? Well, there's no more composite function here, so we don't need to continue that saying something. So what is the derivative of x squared plus x cubed? 2x plus 3x squared. So to write this in the cleanest form, maybe we can take out an x and we get 2 and then maybe we can play with this here. So 4x, 2 plus 3x, and then we've got what? We could take out an x squared. Okay, now this is x to the 6th, so we can get 4x to the 7th, and then we've got and then I guess it's cleaner to put the x's first. I mean, it's all, I guess, personal preference, but 3x plus 2. Yeah, there we go. Okay, chain rule. We've got the derivative of the square root of something. What is the derivative of the square root of something? Well, I've got this memorized by now, but if you don't have it memorized, then use, okay, yeah, well, what is the derivative of x to the 1/2? It's 1/2 x to the 1 minus 1/2 minus 1/2. This is what? 1 over 2x to the 1/2, so 1 over 2 root x. Okay, so the derivative of the square root of something is 1 over 2 times the square root of that something times the derivative of that something. What is the derivative of arctangent x? Okay, here's arctangent, 1 over 1 plus x squared. So the derivative of arctangent x is, we've got 1 plus x squared. Right, there's no more composite function here. We're just finding the derivative of arctangent of x. There's no more, we're not saying 1 plus something squared, all that under 1. This is it. Okay, so now, I mean, that's it. Just write it just in a the cleanest form you can. I'm going to put tangent minus 1. So 2, 1 plus x squared, oh no. And there you go. Okay, we need to use the chain rule here. So what is the derivative of the square root of something? This sine square root of x, that's all a function, just a function of x. So 1 over 2 times the square root of that something. Okay, times the derivative of that something, the derivative of the sine of square root of x. We have to use the chain rule again. What is the derivative of the sine of something. It's cosine of that something times the derivative of that something. What is the derivative of the square root of x? This is the last, we don't have any more layers to go. It's just 1 over 2 square root of x. Now let's just write this in the cleanest form we can. So 2 times 2 is 4. Now the square root of sine root x times root x. We can combine those to get x sine root x all under one root. There you go. Okay, we can use the quotient rule here. We have one function of t over another function of t. Quotient rule, derivative of the top is what? There's no chain rule in this problem. We don't have to use the chain rule. Derivative of the top, just 4t cubed times the bottom minus derivative of the bottom. This is also 4t cubed times the top all over the bottom squared. That's the derivative. Let's just simplify it as much as we can. So we can factor out a 4t cubed, and we're left with t to the fourth plus 1 minus t to the fourth plus 1. We have to distribute this minus sign. So these subtract out. 1 plus 1 is 2, so we're left with and that's the derivative. Okay, here we can use the product rule. This is one function of x, just this x here, and then another function of x is inverse cosine of x. So the derivative of the first, the derivative of x is just 1, times the second, plus the derivative of the second. What is the derivative of inverse cosine of x? Minus 1 over the square root of 1 minus x squared. Okay, so minus 1 over the square root of 1 minus x squared times the first. So the derivative of the first times the second plus the derivative of the second times the first. So we've got that's the derivative. Okay, we've got one function of x multiplied by another function of x. We can use the product rule. So the derivative of the first, what is the derivative of the square root of x? It's 1 over 2 root x times the second plus the derivative of the second. So we need to use the chain rule here. What is the derivative of the cosine of something? It's minus sine of that something times the derivative of that something. What is the derivative of square root of x? It's 1 over 2 root x. And that's it. We're done with that's the derivative of cosine of root x. So the derivative of the first times the second plus the derivative of the second now times the first. Okay, so now let's just clean this up. That's the derivative, but let's clean it up. Okay. And that's the derivative. Okay, so let's write this as x plus root x to the minus 1/3. Okay, so let's find y prime using this form. Okay, chain rule. What is the derivative of something to the minus 1/3 power? Minus 1/3 times that something to the minus 1/3 minus 1. So minus 4/3 power. Okay, times the derivative of that something. What is the derivative of x plus root x? So there's no more chain rule. The derivative of x is 1. The derivative of root x is 1 over 2 root x. That's the derivative. Just need to clean it up. So we've got so let's multiply by 1 in the form of 2 root x over 2 root x. So we're left with and that's the derivative. Okay, we need to use the chain rule here. Looks like 3 times. What is the derivative of inverse tangent of something? 1 over 1 plus that something squared. Okay. 1 plus okay, times the derivative of that something. What is the derivative of inverse sine of something? That's 1 over the square root of 1 minus that something squared. Times the derivative of that something. What is the derivative of the square root of x? This is the last step in the chain rule. 1 over 2 root x. There we go. So now let's just clean this up. We can bring this x inside of this root. So and that's the derivative. Okay, here y is defined implicitly, so we need to use implicit differentiation. Implicit differentiation isn't in one of our derivative techniques or rules. This is really you just using the chain rule. So implicit differentiation, what we do is we take the derivative of the entire equation with respect to the independent variable, and then from there we solve for y prime. Okay, so what is the derivative with respect to x of x times e to the y? Well, okay, e to the y is a function of x, right? Because we have y of x. This we can use the product rule here. So the derivative of the first, like this is one function of x, this is another function of x. The derivative of the first, 1 times the second, plus the derivative of the second. Now we need to use the chain rule. What is the derivative with respect to x of e to the y? Or e to the something? It's just e to the something times the derivative of that something. Okay, so we've got the derivative of the first times the second plus the derivative of the second times the first. Okay, d dx of just y, that's just y prime, and then d dx of a constant is 0. So now let's solve for y prime. Let's bring all the y prime terms on one side. Okay, so now factor out of y prime. Okay, so y prime is and that's the derivative. Okay, we need to use the chain rule here multiple times. So what is the outermost function type? It's the square root of something. What is the derivative of the square root of something? 1 over 2 square root of that something. Times the derivative of that something. Okay, so what is the derivative of t natural log of t to the fourth? We need to use the product rule. Now make sure you put a parentheses here because we're gonna have things like one thing plus another thing. All of that is multiplying this initial part. Okay, product rule, the derivative of the first, 1, times the second, plus the derivative of the second. Okay, chain rule here. What is the derivative of the natural log of something? It's 1 over that something times the derivative of that something. What is the derivative of t to the fourth? 4t cubed. Okay, let's put this in parentheses. So we have the derivative of the first times the second plus the derivative of the second times the first. Okay, so what have we done? Are we finished? We said we had the derivative of the square root of something is 1 over 2 square root of that something times the derivative of that something. And this is the entire derivative of what's inside the square root. So that's the derivative. But again, let's clean it up. So we've got so and that's the derivative. Okay, chain rule. What is the derivative of the secant of something? It's secant of that something, tangent of that something. So again, the derivative of secant of something is secant of that something, tangent of that something, times the derivative of that something. d dx of 1 plus x squared is 2x. So that's the derivative. Okay, we can use the quotient rule here. We have one function of x over another function of x. So the derivative of the top, the derivative of tangent of x is secant squared of x times the bottom minus the derivative of the bottom. What is the derivative with respect to x of 1 plus cosine of x? That's minus sine of x times the top all over 1 plus cosine of x squared, the bottom squared. So again, that's the derivative, but you want to clean it up. So we've got and that's the derivative. Okay, chain rule. What is the derivative of the natural log of the absolute value of something? Okay, that's just 1 over that something. We can just get rid of the absolute value, just remove it. So 1 over this is just the reciprocal of this fraction. So we put x squared minus 4, and then... So this is the derivative of the natural log of the absolute value of this something times the derivative of that something. I mean, we actually could have simplified this by splitting this up into natural log of the absolute value of x squared minus 4 minus natural log of the absolute value of 2x plus 5, but we can do it this way as well. So all of that times the derivative of this. There's no more chain rule, but we have to use the quotient rule here. So, okay, the derivative of the top, 2x. Let me put... Okay, the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, that's the derivative. So one thing we can see is this cancels. So we've got, and then we have okay, now this here in the denominator, we've got 4x squared plus 10x minus 2x squared plus 8. So 2x squared plus 10x plus 8. So now if we factor out a 2, okay, now can we factor this? So yeah, 4 times 1, so x plus 4, x plus 1. So we've got, and then 2, and let's put x plus 1 first. There we go, that's the derivative. Okay, chain rule. What is the derivative of the natural log of something? It's 1 over that something times the derivative of that something. So what is the derivative of the hyperbolic cosine of 3x? So this is the chain rule again. What is the derivative of the hyperbolic cosine of something? It's hyperbolic sine of that something. So, okay, times the derivative of that something. What is the derivative of 3x? Okay, so we've got now, similar to regular trig functions, the hyperbolic sine of something over the hyperbolic cosine of something is the hyperbolic tangent. So and that's the derivative. Okay, we can write this as and use the product rule. So derivative of the first. What is the derivative of e to the 1 over x? We need to use the chain rule. So the derivative of e to the something is just e to that something times the derivative of that something. What is the derivative of 1 over x? That's minus 1 over x squared. So the derivative of the first times the second plus the derivative of the second. What is the derivative of x to the minus 2? That's minus 2x to the minus 2 minus 1 and minus 3 times the first. Okay, so we've got, and then this is minus x to the minus 2, and then okay, and then we've got x, and then minus 2 e to the 1 over x. So let's factor out and minus e to the 1 over x. So we've got and that's the derivative. Okay, so perhaps we want to use the chain rule here. What's the most general function? Is this an exponential? So, well, no, this is derived for where b is a number, is a real number. B is not a function of x. We have a function of x as the base. And that we definitely can't use the power rule. We can't say bring down the x and subtract and then put x minus 1. This is a variable as the exponent. But remember, what you can always try is logarithmic differentiation. Let's give that a shot. So take the natural log of the entire equation. So we've got okay, now let's simplify this. Okay, now let's take the derivative with respect to x of the entire equation. So we've got 1 over y prime is equal to, let's use the product rule here. So the derivative of the first is 1 times the second plus the derivative of the second. We need to use the chain rule here. So the derivative of the natural log of something is 1 over that something times the derivative of cosine of x is minus sine of x, okay, times the first. So the derivative of the first times the second plus the derivative of the second times the first. So we've got, and then so sine of x over cosine, well, this becomes positive. No, this is negative. Okay, now we've got sine of x over cosine of x is tangent of x, so this is x tangent of x. Okay, multiply this entire equation by y, and we've got y prime is equal to y okay, so now just substitute in y back in here, and we've got y prime is equal to cosine of x to the x power and there we go. That's y prime. Okay, here's another one I'm tempted to use, logarithmic differentiation, but this is an exponential form. So we have a real number base to some function of x. So let's go ahead and use the chain rule with the differentiation of exponentials. So the derivative of some number to the x power is b to the x times natural log of b. So the derivative of 3 to the something power using the chain rule is just rewrite 3 to that something and then times natural log of 3. Okay, now times the derivative of that something. So what is the derivative of x natural log of x? We need to use the product rule. I'm going to put a big bracket here just to make sure that we're multiplying all of this times this. Okay, derivative of the first, 1, times the second, plus derivative of the second times the first. Okay, so we've got and then these cancel, and we've got natural log of x plus 1. And that's it. That's the derivative. Okay, we can use the product rule here. Here's one function of x, and here's another function of x. So, okay, the derivative of the first is 1 times the second, plus the derivative of the second. What is the derivative of the hyperbolic sine of something? Hyperbolic cosine. So okay, times the derivative of that something, so 2x, times the first. So the derivative of the first times the second, plus the derivative of the second, all of this, times the first. So we've got 2x squared there we go. Okay, so we can just get this derivative by itself and then this derivative by itself and just add, use the sum or the sum and difference rule. So chain rule here, what is the derivative of natural log of something? 1 over that something times the derivative of that something. Derivative of sine of x is cosine of x. Okay, minus 1/2 times, what is the derivative of sine squared of x? Chain rule again. What is the derivative of something squared? It's 2 times that something times the derivative of that something. There we go. Okay, so we've got cosine of x over sine of x is cotangent of x, and then minus sine x cosine of x. That's the derivative. Okay, chain rule, we've got something to the negative 1 power. What is the derivative of something to the negative 1 power? Minus 1 times that something to the minus 1 minus 1. Okay, times the derivative of that something. What is the derivative of 1 minus x to the minus 1? There's no more composite function here, so we're done with the chain rule. We just need to find what is the derivative of 1 minus x to the 1. So this is 0. The derivative of minus x to the 1, we bring down the minus 1, so we're just left with x. Now to the minus 1 minus 1 minus 2. Okay, so y prime is equal to, we've got x squared 1 minus 1 over x squared. And then we can actually simplify this a little bit more. We can say x 1 minus 1 over x squared. And then maybe let's do this. Let's keep simplifying that denominator. So if we distribute, we got x minus 1. Oh, there we go. Yeah. Okay. So yeah, that's the derivative. Okay, chain rule. What's the derivative of the natural log of something? It's 1 over that something times the derivative of that something. Product rule. Derivative of the first times the second plus derivative of the second times the first. Okay, so we've got, and then 1 plus natural log of x. We could try distributing this and see. No, let's just leave it. We can bring this into one fraction, so 1 plus, yeah, there we go. That's the derivative. Okay, chain rule. What is the derivative of cotangent of something? Minus cosecant squared of that something. So minus cosecant squared, okay, times the derivative of that something. What is the derivative of 3x squared plus 5? 6x. All right, so minus 6x cosecant squared 3x squared plus 5. Okay, chain rule. We have e to the some function of x. What is the derivative of e to the something? It's just e to that something. Okay, times the derivative of that something. What is the derivative of x secant x? There's no more chain rule here, but we do have to use the product rule. So the derivative of the first times the second plus the derivative of the second. What is the derivative of secant x? Secant x tangent x. Okay, derivative of the first times the second plus the derivative of the second and then times the first. We'll put the x there. Okay, so we've got, we can take out a secant x e to the x secant x, and then we've got 1 plus x tangent x, and that's the derivative. Okay, chain rule. We have the natural log of some function of x, or the natural log of the absolute value of some function of x. So what is the derivative of the natural log of the absolute value of something? It's just 1 over that something. You can just take off the absolute value. This is one of those derivatives that's nice. That's why e and natural logs are great with derivatives. This is one of the reasons. See, natural log of x is 1 over x, and the derivative of natural log of absolute value of x is just 1 over x. Okay, so the derivative of the natural log of the absolute value of something is just 1 over that something. Okay, times the derivative of that something. Now we want to put a big bracket here because all of this is multiplying this here. Okay, what is the derivative of secant 5x plus tangent 5x? We're done with the chain rule. Or no, we're not done with the chain rule, actually. We've got each of these, we'll have to use the chain rule. So, okay, what is the derivative of secant 5x? So, chain rule, what is the derivative of the secant of something? Secant, that's something, tangent, that's something. Okay, so secant, that's something, tangent, that's something, times the derivative of that something. Derivative of 5x is just 5. Let's put that here. Okay, derivative of tangent 5x. Chain rule again. What is the derivative of tangent of something? That's secant squared of that something. So secant squared of that something times the derivative of that something. Derivative of 5x is 5. All of this is multiplying this here. Okay, so we can factor out a 5 secant 5x. Okay, so we've got times, and then tangent 5x plus secant 5x. Okay, these are the same, so we're left with five secant 5x. That's the derivative. Okay, here we're finding that this is y as a function of x, and this is just a constant. Okay, so let's find y prime of x. We're going to use the quotient rule here. So derivative of the top, chain rule. We've got something to the fourth power. The derivative of something to the fourth power is 4 times that something cubed times the derivative of that something. The derivative of x plus a constant is just 1. Okay, so that's the derivative of the top times the bottom minus the derivative of the bottom is just 4x cubed times the top all over the bottom squared. Okay, that's the derivative. Let's just simplify. So we can factor out a 4x plus lambda cubed, and we're left with, okay, so minus, and then okay, we can continue to simplify. We've got here x to the fourth plus, okay, minus x to the fourth okay, so we've got lambda to the fourth minus lambda x cubed. We can factor out a lambda, and we've got and there you go. That's the derivative. Okay, chain rule. What is the derivative of the tangent of something? Secant squared of that something. So times the derivative of that something. Okay, what is the derivative of t over 1 plus t squared? Let's use the quotient rule. So the derivative of the top times the bottom minus the derivative of the bottom, 2t, times the top all over the bottom squared. And actually, okay, we have this is t squared, it's 1 plus t squared squared. Okay, so now let's simplify. So we've got 1 plus t squared minus 2t squared, which is 1 minus t squared. Okay, so the derivative is Okay, here's one that, this would take a while to use the quotient rule, so let's consider logarithmic differentiation. It looks like that should work and make it significantly easier to do. So let's take the natural log of the entire equation. So we've got natural log of y is equal to, so we'll have the natural log of this entire function of x. We can separate that into the natural log of the numerator minus the natural log of the denominator. So the natural log of minus the natural log of the denominator. Okay, so now we can separate this into the natural log of this plus the natural log of this. Okay, we can bring down this 7 to the front of the logarithm. Okay. Here we can bring, this is x plus 1 to the 1/2, so we can write it like this. We can bring down this 5. Okay, so now that's simplified. Let's go ahead and take the derivative with respect to x. So we've got 1 over y prime, and this is 1 over x plus 1. We use the chain rule, but the derivative of x plus 1 is just 1, so okay. Here, derivative of natural log of 2 minus x is 1 over 2 minus x, and then times the derivative of 2 minus x, so minus 1. So we've got minus 5 over 2 minus x. We can take out a minus from the denominator and make that x minus 2, and so turn this into just positive 5 over x minus 2. Okay, now derivative of natural log of x plus 3 is 1 over x plus 3, and then times the derivative of x plus 3 is just 1, so this is 7 over x plus 3. All right, now if we multiply this entire equation by y, we get y prime is equal to y times this. So just substitute y back in. And we get that y prime is equal to okay. And there we go. That's the derivative. Okay, product rule. Here's one function of x. Here's another function of x. Derivative of the first, 2x, times the second, plus derivative of the second. Chain rule. What is the derivative of the sine of something? It's cosine of that something times the derivative of that something. What is the derivative of pi x? Just pi. Okay, so the derivative of the first times the second plus the derivative of the second times the first. So we've got we can factor out an x. And that's the derivative. Okay, just multiple layers of the chain rule here. Okay, what's the the outermost function type here. You got to think about this carefully. The most general function type here, this is a tough one. It's something squared. It's sine of something squared. Like it's hard to see the squared here, but we've got some function of x squared. That's like the outermost function. What is the derivative of some function of x squared? It's 2 times that something. Right? Okay. 2 times that something. We're done with the first step of the chain rule. Times the derivative of that something. We've got a bunch of layers here, so I'm going to put a big bracket. Okay, the derivative of that something. What's that something? That's everything that was inside the squared. So that's this cosine of the square root of sine pi x. Okay, what's the outermost function here? It's sine of something. What is the derivative of sine of something? Cosine of that something. Okay, times, and so remember we have this big bracket because all of this is going to be multiplying the original, it's all, we have to make sure we know what's multiplying what, which usually only gets confusing if you've got like a product rule or some sum of functions mixed in, because you have to make sure that you're multiplying that entire sum by what came before it. So I think everything's going to be multiplying, so it doesn't matter here. But okay, so what's the next layer? We just did the sine of something, was the cosine of something, times the derivative of that something. Now we're doing the derivative of this. What is the derivative of cosine of something? It's minus sine of that something. So minus sine of that something. Okay, times the derivative of that something. What's next? Sine? No. Square root. What is the derivative of the square root of something? It's 1 over 2 square root of that something. Times the derivative of that something. We still have another layer of the chain rule to go. The derivative of the sine of something is cosine of that something. Times the derivative of that something. Last layer. What is the derivative of pi x? There we go. That's about as hard of a chain rule problem as you're going to get. So let's write this out. We've got 2 pi or minus 2 pi. Well, actually okay, so these are going to cancel. So we've got minus pi okay, these will cancel. Or no. This is an argument of the sine here. Actually, we've got, okay, we can say, so minus pi, we'll put, okay, yeah, there we go. Now we've got sine, okay, and then all over, and there we go. All of this is the derivative. Okay, y is implicitly defined here, so let's use implicit differentiation to find y prime. We start by, we take the derivative of the entire equation with respect to the independent variable. So we've got Okay, so this is just y prime. Here we've got one function of x times another function of x. Cosine of y is a function of x because you have y as y of x. So let's use the product rule. The derivative of the first is 1 times the second plus the derivative of the second. What is the derivative of cosine y? We need to use the chain rule. The derivative of the cosine of something is minus sine of something times the derivative of that something, y prime, okay, times the first. Derivative of the first times the second plus derivative of the second, all of this, times the first. Okay. Now here, product rule again. Derivative of the first, 2x, times the second, plus derivative of the second, y prime, times the first. There we go. So now let's just solve for y prime. Okay, let's bring all of the y prime terms to one side. Now factor out a y prime. Now divide by this term to solve for y prime. Okay, that's the derivative. Okay, product rule. We have one function of x and we have another function of x. This m and this n are constants. Derivative of the first, derivative of e to the mx, chain rule. What is the derivative of e to the something? It's e to that something times the derivative of that something. Derivative of mx is m. Okay, derivative of the first times the second plus derivative of the second. What is the derivative of cosine in x? Chain rule. Derivative of cosine of something is minus sine of that something times the derivative of that something. Derivative of nx is n. Okay, so where are we here? Derivative of the first times the second plus derivative of the second times the first. Okay. All right, let's factor out an e to the mx. And we get and that's the derivative. Okay, you could potentially consider logarithmic differentiation, but it shouldn't be too bad to use the quotient rule. So, okay. This is y is a function of u here, but what's the outermost function? We have some function of u to the fourth power. What is the derivative of some function of u to the fourth power? It's 4 times that function to the third power times the derivative of that function. Okay, what is the derivative of this? There's no more chain rule here. This is just the quotient rule, right? There's no composite function in here. Okay, so derivative of the top is just 1 times the bottom minus derivative of the bottom, 2u plus 1 times the top all over the bottom squared. Okay. So we've got u squared plus u plus 1 minus 2u squared minus 2u plus u is minus u minus 1 Okay, so this is, we've got u squared plus u plus 1 minus 2u squared plus u plus 1. So minus u squared plus 2u plus 2. Okay, so now we can distribute this cubed. So we'll have u squared plus u plus 1 cubed, and then we can combine that here. So y prime is, we've got and then this would be to the 5th power. Okay, that's the derivative. Okay, chain rule. We've got the sine of some function of x. What is the derivative of the sine of something? Cosine of that something. Times the derivative of that something. Chain rule again. What is the derivative of tangent of something? Secant squared of that something. Times the derivative of that something. What's next? More chain rule. We have the square root of something. What is the derivative of the square root of something? 1 over 2 root that something. Times the derivative of that something. This is the last step. We have no more composite functions, so what's the derivative of 1 plus x cubed? 3x squared. Okay, so y prime is equal to okay, that's the derivative. Okay, let's write this as, this is 1 over x to the 1/2, so this is x to the minus 1/2, and then this is 1 over x to the 3/5, so this is x to the minus 3/5. Okay, so now let's just use the power rule. The derivative of x to the minus 1/2. Bring down the minus 1/2. X to the minus 1/2 minus 1. Minus 3/2. Okay, now this will be a plus because we're going to bring down that 3/5. Okay, now minus 3/5 minus 1. Minus 8/5. Okay, so this is the derivative. Let's just write this in the cleanest form that we can write it in. So we've got 2 square root of x cubed over 1, or all that under 1. This is minus. Okay, now this is going to be 3 over 5x to the 8/5. What is x to the 8/5? That's x to the 8, the 5th root of x to the 8. Well, okay, we have x to the 5th times x cubed. So we can take out an x, like, x to the 5th comes out as x. that's the fifth root of x to the eighth. So we've got 5x and there we go. That's the derivative. Okay, product rule. We've got one function of x times another function of x. Derivative of the first times the second plus derivative of the second. Chain rule. What is the derivative of the inverse hyperbolic tangent of something? 1 over 1 minus that something squared. So 1 minus that something squared. 1 over 1 minus that something squared. Times the derivative of that something. What is the derivative of the square root of x? That's 1 over 2 root x. Okay, derivative of the first times the second plus derivative of the second times the first. Okay. So we've got x over root x. This cancels and this becomes root x because 1 minus 1/2 is positive 1/2. So we've got, and this becomes 1 minus x. So 2, 1 minus x. And that's the derivative. Okay, chain rule. We've got the log base 5 of some function of x. What is the derivative of the log base 5 of something? Okay, it's 1 over that something times the natural log of the base. Okay, so the derivative of log base 5 of some function of x is we've got times the derivative of that something. What is the derivative of 1 plus 2x? 2. So that's the derivative. Okay, chain rule. What is the outermost function here? We've got some function of theta squared because this is tangent sine theta squared. So what is the derivative of something squared? We use the power rule. So 2 times that something times the derivative of that something. Chain rule again. What is the derivative of tangent sine theta? Okay, well, we have the tangent of some function of theta, the tangent of something. What is the derivative of the tangent of something? It's secant squared of that something times the derivative of that something. What is the derivative of sine theta? Cosine theta. So that's the derivative. Okay. Chain rule. What is the derivative of e to the something? It's just e to that something times the derivative of that something. The derivative of cosine of x is minus sine of x. Okay. Chain rule again. What is the derivative of cosine of something? It's minus sine of that something times the derivative of that something. What is the derivative of e to the x? Just e to the x. So we've got That's the derivative. Okay, chain rule. What's the outermost function here? It's something squared. Okay, so power rule. What is the derivative of something squared? It's 2 times that something times the derivative of that something. What is the derivative of, we have to use the chain rule again, arc sine of something. 1 over the square root of 1 minus that something squared. So 1 over the square root of 1 minus that something squared times the derivative of that something. What is the derivative of 2x? Okay. So we've got okay, that's the derivative. Okay, m is a constant here. Y is a function of x, so we can use the quotient rule. The derivative of the top. Okay, chain rule. What is the derivative of sine of something? It's cosine of that something. Times the derivative of that something. What is the derivative of mx? That's just m. Okay, derivative of the top. Well, we'll do, okay, is times x. So we have mx cosine of mx, right? The derivative of the top is cosine of mx times m times the bottom, there's the x, minus derivative of the bottom, 1, times the top, all over the bottom squared. So that's the derivative. Okay, chain rule. What is the derivative of cosine of something? It's minus sine of that something. Times the derivative of that something. What is the derivative of e to the something? It's just e to that something. Times the derivative of that something. What is the derivative of the square root of something? 1 over 2 root of that something. Times the derivative of that something. What is the derivative of tangent of something? It's secant squared of that something. Times the derivative of that something. What is the derivative of 3x? Okay, so let's just clean this up. And that's the derivative. Okay, chain rule. We have 10 to some function of theta. What is the derivative of 10 to the something? That's an exponential. It's natural log of 10 to that something, times the derivative of that something. What is the derivative of tangent of something? Secant squared of that something, times the derivative of that something. What is the derivative of pi theta? Pi. That's the derivative. Okay, so y is implicit here. let's use implicit differentiation to find y prime. Take the derivative with respect to x of the entire function. So we've got okay, so derivative with respect to x of sine xy. What is the derivative of sine of something? It's cosine of that something times the derivative of that something. What is the derivative of xy? Product rule. Derivative of the first, just 1, times the second, plus derivative of the second times the first. So that's x y prime. Okay, d dx x squared is just 2x, and then d dx of y is just y prime. Okay, so now solve for y prime. We've got y cosine of xy plus okay, now let's bring the y prime terms together. Now let's factor out a y prime here. Okay, so y prime is equal to that's the derivative. Okay, product rule. Here's one function of x, here's another function of x. The derivative of the first is 1 times the second. Plus derivative of the second. What is the derivative of inverse tangent of 4x? The derivative of the inverse tangent of something is 1 over 1 plus that something squared. Times the derivative of that something. Derivative of 4x is 4. Okay, so y prime is okay, I'm missing an x here. So this was the derivative of the first times the second plus the derivative of the second times the first. So that's the derivative. Okay, y is defined implicitly here. Let's use implicit differentiation. Take the derivative with respect to x of the entire equation. Okay, product rule, derivative of the first times the second plus derivative of the second. What is the derivative of e to the something? E to that something times the derivative of that something. So derivative of the first times the second plus derivative of the second times the first. Okay, product rule again. Derivative of the first times the second plus derivative of the second times the first. Okay, now let's solve for y prime. So we've got x y prime e to the y minus y prime sine of x is equal to y cosine of x minus e to the y. Factor out a y prime. So y prime is equal to And that is the derivative. Okay, chain rule. What is the derivative of the natural log of something? It's 1 over that something times the derivative of that something. What is the derivative of secant x? It's secant x tangent x. Okay? This is tangent x. Okay, chain rule. What is the derivative of the cotangent of something? It's minus cosecant squared of that something. Times the derivative of that something. What is the derivative of cosecant x? Minus cosecant cotangent x. Okay, so these minus signs combine to give a positive, so we're left with that's the derivative. Okay, let's use the quotient rule. Derivative of the top. What is the derivative of x squared minus x plus 2? That's 2x minus 1 times the bottom minus the derivative of the bottom. What is the derivative of square root of x? 1 over 2 root x times the top all over the bottom squared. Okay, so let's combine everything in the numerator here. 2 times x to the first times x to the 1/2. That's 2x to the 3/2 minus x to the 1/2. Okay, now minus 1/2, so x squared over x to the 1/2. That's x to the 3/2 minus, or no, this would be plus x to the first divided by x to the 1/2. That's x to the 1/2. Okay, now plus x to the minus 1/2. Or no, this would be negative. Okay, so 2x to the 3/2 minus 1/2 x to the 3/2. That's 3/2 x to the 3/2 minus x to the 1/2 plus 1/2 x to the 1/2. That's minus 1/2 x to the 1/2 minus x to the minus 1/2. Okay, now let's separate these out into separate fractions. So we've got 3/2 x to the 3/2 minus 1 x to the 1/2, so square root of x. Okay, 1/2 x to the 1/2 divided by x to the first. That's x to the minus 1/2, so 2 root x, 1 over 2 root x. Okay, x to the minus 1/2 over x to the first. So that's minus 1/2 minus 1 is x to the 3/2. X to the 3/2, that's the square root of x cubed, which is, that's x root x. Okay, so this is 1 over x root x. There we go. That's the derivative.